Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, today we are going to discuss, or I'm going to explain to you, in topic of what we call 5.4 exponential and log function and trigonometric function. So this is the last final part for we call topic 5, lecture 404. Okay, so I do hope that all of you get ready with your lecture notes in your hand. So without waiting so much time, let's continue. So we are going to look at exponential and log function. So in this topic, students should be able to find the relationship of exponential and log function by algebraic and graphical approach. Okay, so especially for this one here, graphical means that you need to be good in sketching a graph. Find the domain and range of exponential and log function. Find the composite function involving exponential and log function and sketch the graph of exponential and log function on the same axis. Okay, so the relationship of exponential and log function here, okay, the inverse of exponential function of fx equal to, okay, the inverse of exponential function fx is we call log x to the base of a, and log function are the inverse of exponential function. Okay, so then for example, most of the time we're gonna see what we call a function of y equal to x squared. Okay, I do believe that all of you have seen this kind of function before. Y equal to x squared is a curve, and then we have a minimum or maximum point with something like this. Okay, so but right now when you have 2 to the power of x, then is related with the exponential function. This is an exponential function. Okay, so then just imagine that if x equal to -2, y equal to 2 to the power of -2, as we know that a to the power of -n equal to 1 over a to the power of n. So for this one here now, it is 1 over 2 square or 1 over 4. There you go. Okay, and then when x equal to -1, y equal to 2 to the power of -1, which is 1 over 2 power of 1, or it is 1 over 2. Okay, 1 over 2. And when x equal to 0, any value of, we call any value here beside 2 is either 3, 4, 5, 10, 50, or 100, and just name it any value, to the power of 0 will equal to 1. And when x equal to 1, 2 to the power of 1 equal to 2. And when x equal to 2, 2 square equal to 4. And when x equal to 3, 2 cube, 2 power of 3 equal to 8. Okay, so this is what we call the beginning of our discussion of exponential function. And let's plot the graph. When x equal to -2, y equal to 1 over 4 here. Okay, when x equal to -1, y equal to 1 over 2. When x equal to 0, y equal to 1. When x equal to 1, y equal to 2. Okay, and so on. And we make a line according to these all dots or plots here, and we get y equal to 2 to the power of x. So this is one example of exponential graph. And then for we call opposite or inverse of the function of exponential is log. Okay, log is an inverse to the exponential function. Now with the log equal to x to the base of 2. So the base of 2 here, this is the base, and then log x to the base of 2. Now you may use a calculator for this one here. Okay, so substitute x with -2. Okay, substitute x with negative. Okay, no, this one here, x. Substitute x with 1 over 4. Log 1 over 4 to the base of 2, which is log, it is 1 over 2 square to the base of 2, or log 1 over 2 square, which is 2 to the power of negative 2, base of 2 here, and then bring this negative 2 to the front, negative 2, log 2 to the base of 2, as we know that log 2 to the base of 2 equal to 1. So 1 multiplied with negative 2 equal to negative 2. There you go. So the same process, if you substitute the value of x equal to half, 1, 2, 4, and 8, then you'll get y equal to, as a list down here. So let's plot all the coordinate, 1 over 4 with y negative 2, x 1 over 2 with y equal to negative 1, 1 by 1 here. And we make a line according, we call based on this, all this coordinate, then you name it this one as a y equal to log x to the base of 2. So guys, girls, between these two, this is fx and this is the inverse actually. Okay, then we have a line of y equal to an x. We have a line in between here actually. Okay, it's not very clear, so this is y equal to an x. So log function are the inverse of exponential function, then the inverse of exponential function is y equal to log x to the base of a. Okay, now exponential function fx equal to a to the power of x. Okay, and for this one, inverse a, not inverse, but fx equal to a to the power of negative x. So opposite of fx, this one here, a to the power of x, and this one, fx equal to a power of negative x. So that's makes difference between these two. And guys, girls, actually that, if I add something, okay, as we know that when x equal to 0, any numbers to the power of 0, any numbers to the power of 0 will equal to 1. Okay. Okay, class. If I add something here, we may also sketch a graph something like this, where this fx equal to negative a to the power of x. Okay, where all the positive value of a to the power of x, once we multiply with negative, then everything goes to, it become negative and reflects through the x-axis from this graph way down here. Okay, so, and then another one, this one here, and this is fx equal to negative a to the power of negative x. So all the positive value of this function, a power of negative x, we reflect through the x-axis, and we call, it came down here, fx equal to negative a power of negative x. Okay, so horizontal asymptote y equal to 0, meaning that the graph will continuing, so we call getting close to the x-axis, but it won't touch or intersect the axis at all, because there's no value of y equal to 0 for this function. Okay, so sketch the graph and find the range, the domain and range of this function fx. A class, for this one, 1 over 2 is also considered as 2 to the power of negative 1 x, or 2 to the power of negative x. Okay. Okay, so, nope, sorry. x-axis and y-axis. Okay, class. To sketch this kind of function, what you call graph of exponential and log function, I do strongly suggest that we use this idea or approach to sketch this. Okay. Firstly, when we come up with the idea of when x equal to 0. When x approaching to positive infinity, meaning that the value of x is getting bigger and bigger to the positive infinity. And then when x approaching to negative infinity, meaning that the value of x is getting smaller, negative value here to the negative infinity. Okay. Okay, now when x equal to 0, let's find this one here now. Look at this. Okay, f0 equal to 2 to the power of negative 0. Okay, this is 0 here, 2 to the power of 0 equal to 1. So when x equal to 0, y equal to 1 here. And then when x approaching to positive infinity, so then fx approaching to, okay, just imagine that for this one here, 2 power of negative, okay, 2 power of negative x, and the value of x itself is positive, okay, 2 power of negative 2, it gives you 1 over 4, 2 power of negative 3, which is 1 over 2 cube, or 1 over 8, 2 power of negative 5, or 1 over 2 power of 5, or 1 over 32. So when x is getting, when the value of x is getting bigger, then fx, look at this one here, 0.1 over 4, 0.25, 1 over 8, 1 over 8, wait. Okay, 1 divided by 8, it is 0.125. 1 over 32, it is 0.03125. Sorry. Okay, so when x is getting bigger, 2, 3, 5, 8, 10, and so on, then the whole function 2 power of negative is getting smaller and smaller, approaching to the smallest value we call very close to 0. So we consider that as an equal to 0. So then this one here, fx equal to 0. Sorry again. Fx approaching to 0. And when x approach to negative infinity, okay, when x equal to negative 2, x equal to negative 3, x equal to negative 5, so then fx, f negative 2 equal to 2 power of negative, negative 2. Negative times negative, positive, so 2 squared equal to 4. When x equal to negative 3, then 2 power of negative, negative 3, negative times negative, positive, so 2 times power of 3 equal to an 8. And so on, f negative 5 equal to 2 power of negative, negative 5 equal to negative, negative, positive, 2 power of 5 equal to 32. So what's our conclusion here? When x is getting smaller negative value, then fx approaching to positive infinity. Okay, so when x approaching negative infinity, then fx approaching to positive infinity. So it's something like this: x approaching to negative infinity and the value of fx or y approaching to positive infinity. And when x approaching to positive infinity, fx approaching to 0. So your graph will be something like this. There you go. So class, this is fx equal to 1 over 2 to the power of x, this one. And let's take a look at the next one here. Okay, sorry. Okay, now okay, and now it's time for fx equal to 2 to the power of x. Okay, so for this one here now, let's say when x equal to 0, when x approaching to positive infinity, and when x approaching to negative infinity. Again, f0 equal to 2 to the power of x equal to 0, 2 power of 0 equal to 1. Okay, the intersect point is still here, x equal to 1. When x approaching to positive infinity, so just imagine that x, 2 power of x, when x equal to 2, then 2 power of x equal to 2 square equal to 4. When x equal to 3, then 2 cube equal to 8. And when x equal to 5, then 2 power of 5 equal to 32. The value of x, 2, 3, 5, 10, and so on, x is getting bigger. And fx is also getting bigger. So then the graph, when x approaching to positive infinity, the value of y approaching to positive infinity. Okay. So then fx approaching to positive infinity. And when x approaching to negative infinity, when x equal to 2, so 2 power of x, where when x equal to negative 2, okay, for example, when x equal to negative 2, so 2 power of negative 2 equal to 1 over 2 square or 1 over 4. When x equal to negative 3, then it is 2 power of negative 3 or 1 over 2 cube equal to 1 over 8. And when x equal to negative 5, then 2 power of negative 5 equal to 1 over 2 power of 5. It is 1 over 32. So what is our conclusion then? When x is getting smaller, negative smaller and smaller than fx, this value approaching to one value which is equal to, which approaching to 0. So fx approaching to 0. So then the graph of this function 2 to the power of x will be something like this. So this is fx equal to 2 to the power of x. Okay, next, sketch a graph and find the domain of this range of this. Okay. I'm sorry. Sorry again. Oh, I'm sorry. The y and x. Okay, so now let's say for question A, when fx equal to 2 to the power of x plus 1. So again, when x equal to 0, when x equal to 0, 2 to the power of f0 equal to 2 to the power of 0 plus 1. 2 to the power of 0 equal to 1, right? And then 1 plus 1 equal to 2. So, when x equal to 0, y equal to 2. This is we call this a coordinate of 0 and 2. And then, when x approaching to positive infinity. So just imagine that when x is getting bigger, 2 power of 2 equal to 4 plus 1 equal to 5. 2 power of 3 equal to 8 plus 1 equal to 9. 2 power of 5 equal to 32 plus 1 equal to 33. When x is getting bigger, what is our conclusion just now? 2 square equal to 4 plus 1 equal to 5. 2 cube equal to 8 plus 1 equal to 9. 2 power of 5, 32 equal to 32 plus 1 equal to 33. So when x is getting bigger, fx also is getting bigger, right? Approaching to positive infinity. Okay. And then when x approaching to negative infinity, 2 power of negative 2 or 1 over 4 plus 1. Okay. 1 over 4 plus 1. And then when x equal to negative 3, so negative 3, 1 over 8 plus 1. And then when x equal to negative 5, 1 over 32 plus 1. Okay, this value 0, 1 over 4, 1 over 8, 1 over 32 is all approaching to 0, right? But then when we have plus 1 here, numbers that are approaching to 0, we consider it as a 0 plus 1, then equal to 1. Meaning, y equal to 1 is now the new horizontal asymptote of this graph. Okay, class. The term of asymptote, the term of asymptote means that a line, okay, asymptote is a line where the graph will moving close to the line, approaching to the line, get too close to the line, but it won't touch or intersect or cut the line at all. Okay, so for this case, fx equal to, okay, approaching to 1. Okay, because we have 1 here. This value approaching to 0, but when it comes to plus 1, 1, okay, equal to approaching to 1. So then now it now becomes, there you go, 2 here. Okay, so this is fx equal to 2 to the power of x plus 1. Okay, the next question, fx equal to 2 to the power of x minus 1. Okay, so then sorry. Okay. Okay, then. Okay, again, when x equal to 0, f0 equal to 2 to the power of 0 minus 1. 2 power of 0 equal to 1. 1 minus 1 equal to 0. Okay, when x equal to 0, y equal to 0. This is the intersection point. Okay. When x approaching to positive infinity, then fx equal to, okay, let's say look at to this 2 power of x. When x is getting bigger and bigger, x equal to 2, 3, 4, 5, 10, and so on. So 2 power of 2 equal to 4, 2 cube, 2 power of 3 equal to 8, 2 power of 5 equal to 32, and then minus 1. 2 squared equal to 4 minus 1, 3 is still positive. 2 power of 8, 2 power of 3 equal to 8. 8 minus 1 equal to 7. Yeah, it's still a big number. And 2 power of 5, 32 minus 1, 31. Still a big number, right? So then fx approaching to positive infinity. And then when x approaching to negative infinity, 2 power of negative 2 or 1 over 4. 1 over 4, okay, 2 power of negative 2 minus 1. 2 power of negative 3 minus 1. 2 power of negative 5 minus 1. Okay, just take this. That these numbers, okay, approaching to 0. Okay, 1 over 4 is 0.25, and this one here and 0.03 something approaching to 0. Minus 1, then we assume that it is negative 1. So now, guys, girls, y equal to negative 1 is now the new horizontal asymptote. Okay, intersect at the origin point of 0 and 0 here. So then the graph will be something like this. So this is fx equal to 2 to the power of x minus 1. Get it? Okay. So, class, which I think that the question wants us to find the domain and range. I forgot something here. So, what is the domain and range of this function? The domain is all values of x, right? From negative to positive infinity. All real numbers. And the range is all about y, value of y. So look at this graph, approaching to 1, and positive infinity. So then it is 1 to positive infinity. And what about this one here now? The domain of this function and the range of this function. Again, the domain is all values of x from negative to positive infinity. Negative to positive infinity. And the range, look at this one here, the graph approaching to negative 1. And then above here is all values of y are positive. So then it is negative 1 to positive infinity. Okay. Okay, now sketch the graph of this. So guys, girls, we call normal. Okay, generally for all this kind of function, e power of x, e power of 2x, e power of 1 over 2x. So when x equal to 0 here, here, and here, e power of 0 equal to 1. 2 times 0 equal to 0. E power of 0 equal to 1. 1 over 2 multiplied with 0 equal to 0. E power of 0 equal to 1. Meaning, when x equal to 0, all these three graphs will intersect at one value of y, which is equal to 1. Okay. And for these three graphs, they are actually the same, we call behave. Okay. When x approaching to positive infinity, okay, when x equal to 2, e squared. Okay, class, significantly, if you can find the, we call the meaning of the Euler's constant. The Euler's constant of e here, which approaching to 2.71828 and so on, and find it in YouTube or might be in Google search engine. Find what's so important about this Euler's constant in not just maths but also in engineering, okay, in physics and engineering, and why that we use most of the time in our calculation here. Okay, never mind, because e is not a variable, not just like x where x can be any value, but e has its own values. Okay, just like you learned before, a pi to find the recall, to find the perimeter and also the area of the circle. Pi is 22/7. So it has its own values here. Okay, never mind. It's not about this one here now, right now. Okay, right now, e power of x, when x equal to 2, we have e squared. When x equal to 2, 2 times 2 equal to 4, e power of 4. Right now, just now, when x equal to 2, e now become e squared, e power of 4. And this one, when x equal to 2, 2 divided by 2 equal to 1, e power of 1. The difference is the slope. Okay, the slope or the gradient of each of these is different, especially for this one. It's sliding up faster than e power of x, and e power of half x is sliding, climbing slower than. Okay, so in this case, if I make this one as the first one, the first graph here, this is fx equal to e to the power of x. And then another one, this is fx equal to e power of 2x, because when x is 2 and this double, 2 times 2 equal to 4, so that the gradient is because it's climbing much faster than this. Okay, and then another one, okay, for this, let's not it. Okay, might be something like this. Okay, and this fx equal to e power of 1/2x is climb slower than this and this. Okay, so what is the domain of each of this? The domain is all real numbers from negative to positive infinity, and the range of all these f1, okay, let's say I put this as an f1, f2, and f3. All these three functions, the range are all, okay, approaching to the value of y equal to 0 and positive infinity. 0 to positive infinity. Okay. So now, e power of x plus 1. Sorry again. Sorry. Okay, this is y and x. Okay, so fx equal to e to the power of x plus 1. Okay, when x equal to 0, then f0 equal to e to the power of 0 plus 1, which is equal to e. So e is 2.718 to say something, we just put it here as an e. Okay, and then when x approaching to positive infinity, so when x equal to 2, 2 plus 1 equal to 3. So the index or the power of the constant e is getting bigger. When x equal to 3, 3 plus 1 equal to 4. When x equal to 4 plus 1 equal to 5. So fx approaching to positive infinity. Okay. When x approaching to negative infinity, when x equal to negative 2, e power of negative 2 plus 1, e power of negative 3 plus 1, e power of negative 5 plus 1, e power of negative 10 plus 1. So this one is going to give you e power of negative 1, e power of negative 2, e power of negative 4, and e power of negative 9. Let's try if you can use your calculator. Okay. Okay, so e to the power of okay, -2. Okay, e power of -2 is 0.1353. Sorry. E power of -4. E power of -4, 0.0183. Okay, and then when it comes to power of -9, then it is 0.00001234, so on. So look at this pattern: 0.13, 0.018, 0.00000 something. Okay, it's approaching to 0, am I right? So now for this one here, fx approaching to 0. So class, for this one, the graph approaching to 0, okay, approaching to 0, maybe something like this, and cut at this point, and it's getting bigger and bigger. So this is fx equal to e to the power of x plus 1. Okay. And what is the domain of this function and the range of this function? The domain is all values of x being used here is all real numbers, and the range is approaching to 0 and positive infinity. So then 0 to positive infinity. Okay, there you go. Okay, so then what about this one here? Okay, okay, x and y. So again, when x equal to 0, f0 equal to 2e to the power of 0. E to the power of 0 equal to 1. 1 multiplied with 2 equal to 2. So it cut at 2 here. Okay, so then when x approaching to positive infinity, then fx equal to, when x is getting bigger, 2, 3, 4, 5, and so on. Yeah, I know you can guess. E to the power of 0 is also getting bigger, right? A bigger number. And then this big number multiplied with 2 is getting bigger and bigger, so approaching to positive infinity, the value of y. And then when x approaching to negative infinity, okay, e to the power of x itself, when x is getting smaller and smaller, negative, e power of -2, power of -4, power of -8, this itself, okay, e power of x itself, when x is getting smaller, this approaching to 0, okay, 0.0012, okay, 0.001234 just now, multiplied with 2. Do we bring any, we call, big change on that? No. Okay, it's still approaching to 0. So for this one here now, the graph will be something like this. Okay, so this is fx equal to e to the power, okay, no, 2e power of x. Okay, this one. And what is the domain of this function? The domain is all values of x from negative to positive infinity, and the range is approaching to 0, and the rest is all positive infinity, 0 to positive